Hello and welcome to this lesson for Chemistry 20, the acid-base section of the Solutions Acid-Base unit. Now, in this lesson, we're going to do the opposite of calculating pH and pOH, which is to use the pH and pOH to find the concentration of either the hydronium or the hydroxide ion. Now, what I want you to remember is that the hydronium ion always forms from some type of hydrogen-containing compound. So an acid, something that has a donatable hydrogen, and it donates that hydrogen to water, and that forms your hydronium ion. So you can think of the hydronium ion as being synonymous with the hydrogen ion, and that's what the H in the pH stands for. So if you want to find the concentration, remember square brackets means concentration. So if you're looking for the concentration of the hydronium ion, you need to know the pH, and the formula is 10 to the exponent negative pH. If, on the other hand, you're looking for hydroxide ions, then you need pOH. pOH, the OH standing for, again, hydroxide. So that would be 10 to the exponent negative pOH. So this is not 10 minus pOH, this is 10 to the exponent negative pOH. Okay? Now let's look at some examples. So the first four here, we are given pH, and we are looking for hydronium ions. And then the next four, we are looking for hydroxide, and we are given pOH. Okay, now remember our sig-dig rules. In pH and pOH, only the decimal places were significant. So the number of digits to the right of the decimal place. That in concentration, mass, volume, anything else you're calculating would need to equal its total digits. Okay. So if I have one decimal place in my pH, I need one total digit in my concentration. So again, what you're going to do is go 10 to the exponent negative 4.0 and then hit enter. I just got to grab my calculator here. 10 to the exponent, oh, my calculator's just warming up. 10 to the exponent negative 4.0 gives us an answer of 1, that's my one total digits, times 10 to the negative 4, and now I have units again because these are concentrations. The unit would be moles per liter. Okay, so if we try the next one, 10 to the negative exponent 6.21, so 10 to the exponent negative 6.21, you get an answer. Now I have two decimal places, so I can keep two total digits in my concentration. So my two total digits are 6.2, that rounds from 6.165 so on, times 10 to the negative 7 moles per liter. Okay, so we keep going through using those formulas. 10 to the exponent negative 13.400. Now in this pH, I had 3 decimal places, so I can keep 3 total digits. So that would be 3.98 are my 3 total digits, times 10 to the negative 14 moles per liter. Now what happens, just circling my total digits there, when I have no decimal places? That means I can have no total digits, and my total digits are the number before the times 10 to the negative 4. I can't have that number, which means my answer is only the 10 to the negative 7 moles per liter. I can't have the something times 10 to the negative 7 because there's no decimal places. So no sig-digs, just the exponent. Okay? Now for the next one, I have 1 decimal place. Now, again, I'm looking for hydroxide ions, so I need pOH, which I have. Just reminding you again to remember what scale you need depending on which ion you have. So the answer to this is not in scientific notation. You can put it in scientific notation, but it's just 0.1 mole per liter. In scientific notation, that would be 1 times 10 to the negative 1 mole per liter. So a lot of times it's in scientific notation because the numbers are really small, but sometimes it's not. Either way, we're allowed one total digit. Leading zeros don't count, so that would be my one total digit. Okay, the next one, we have 10 to the exponent negative 13.2. So 10 to the exponent negative 13.2. I have one decimal place, so I can have one total digit. That would be 6 times 10 to the negative 14 moles per liter. Next would be 10 to the exponent negative 6.90. Again, two decimal places, so I can have two total digits. 6.90. Two total digits would be 1.3 times 10 to the negative 7 moles per liter. And the last one, I have 3 decimal places, so I'm allowed 3 total digits. 10 to the exponent negative 0.786 gives me 3 total digits of 164, because leading zeros don't count, moles per liter. Okay, let me just put up the answers, make sure we did all that correctly. And everything looks good. Okay, so don't forget again your sig-dig rules. Now here's a chart that you're going to see come up on a quiz where you're given a list of solutions and you're looking for all of the ions and the number on both the pH and pOH scale. So before doing a chart like this, I would write down your formulas for everything. So in order to find hydronium ion concentration, it would be 10 to the exponent negative pH. To find hydroxide, it would be 10 to the negative pOH. pH is negative log concentration of hydronium, and pOH is negative log concentration of hydroxide. Now also remember, I can get from pH to pOH minusing the other from 14. And then I'm going to also write down my sig-dig rules because I'm going to be going back and forth here. Okay, so these are my concentrations, the first two columns. So I'm going to be looking at their total digits. That has to equal the decimal places in my second two columns because those are my pH and pOH values, which are only decimal places that are significant. So in this first question, for example, so you're imagining that these are different solutions. Solution 1, solution 2, 3, 4, 5, 6, for example. Okay? Now, in solution 1, I am told the concentration of hydronium ion is 4.0 times 10 to the negative 6. I can find the pH from that number by taking the negative log of that number. So negative log 4.0 times 10 to the power of negative 6 gives us an answer of 5.397, so on. Now I have two total digits that are significant in my concentration, so I need 2 decimal places in my pH. Okay, now that I have pH, and again I have pH because I had hydronium ion, hydronium and pH go together, now I can subtract from 14 to have pOH. Now if my pH had 2 decimal places, my pOH also needs 2 decimal places. Okay? And now from that, I can find the concentration of my hydroxide ions because it is going to be, now that I have pOH, 10 to the power of negative pOH. So 10 to the power of negative 8.60. Now I'm looking back at total digits, 2 sig-digs, to match the decimal places in my pOH. Okay, my total digits in concentration equal my decimal places in pH and pOH. Now that I have that, 2.5 times 10 to the negative 9 moles per liter, I'm basically done this first solution. I just have to identify if it's an acid, base, or neutral, right? Now, I usually just look at my pH because we're used to pH. Anything below 7 is an acid. Okay? In order for your solution to be neutral, you have to have exactly 7.0 or 7.00 or whatever. It has to be exactly 7. If it's a little bit above or below, it's not neutral. Okay? Next solution, we are given the pH. So the first thing we're going to do is find the hydronium ion concentration, 10 to the exponent negative 9.500. Now my sig digs in this solution, there are 3 sig digs, 3 decimal places in my pH. So I need 3 sig digs or 3 total digits in my concentration. Now I can subtract my pH from 14 to get pOH. It has to have the same sig digs, which are decimal places, 3 decimal places. And then I can go 10 to the exponent negative 4.500, and that's going to give me my hydroxide ion concentration. Again, I'm going back now to 3 total digits as my sig digs. So that's why, like I said, it's really important to write maybe at the bottom to remind yourself, when am I looking at total digits? When am I looking at decimal places? For concentration, mass, volume, you're always looking at total digits. pH and pOH are the only numbers that you match only its decimal places to the total digits of concentration. Okay, now this pH is greater than 7, so this is a base. Now I'm just going to fill in all the answers here so that if you're giving this a try on your own, you can see how all the answers come to be. Note how sometimes you have really big concentrations and then your pH goes beyond the 0 to 14 scale. You can have a negative pH and a value above 15. Okay? So again, remember your decimal places equal your excuse me, total digits. All right. So the last example that we have is a compounds question again. Notice how these questions were going directly from ion to pH or pH to ion. But what about when you have a compound? So like before when we did pH calculations, remember when you had a compound, you have to first identify what type of compound do you have. Is it an acid or is it a base? Remember, if it's an ionic hydroxide, it is a base, technically a strong base, and in your pH calculations, you're always going to have a strong acid and a strong base. If this were an acid, I would react it with water, but bases do not react with water. Bases just simply dissociate into 1 calcium ion and 2 hydroxide ions because there was 2 hydroxide ions in the compound. Now I want to find the mass of my calcium hydroxide. I am given the pH. Now one thing you should note when you're given pH or whatever you're given, look at the compound you have and see if it matches. pH and hydroxide ions, because again, I'm looking at the ions that I have. Hydroxide ions do not go with pH. I need pOH, okay? So I'm going to find my pOH first with 14 minus my pH. Now again, why do I need pOH? So that I can find the concentration of my hydroxide ions. They can then be the given in my wanted over given ratio. So 14 minus 13.25 gives me a pOH of 0.75. Okay, so now again, indirectly, I have been given the concentration of the hydroxide ions by going 10 to the exponent negative 0.75. So I get a concentration of my given to be 0.177 so on moles per liter. Now my wanted again is the compound this time, okay? Because I'm wanting to find its mass. I know the concentration of the hydroxide ions, I just found them, and now I'm wanting to find the compound. So 0.177, remember you're using this number unrounded. If you can't use an unrounded answer in your calculator, make sure you record the entire number. I'm going to multiply this by 1/2 or divide by 2 to get the concentration of my calcium hydroxide. 0.0889 so on moles per liter. Now I can find my moles with C times V. So the concentration, 0.0889 unrounded moles per liter, times my volume given in the question, 500 mils converted into liters. Make sure you always have liters for this formula. So times 0.5 gives me a mole value of 0.044 so on moles per liter. Oops, that's just moles. My liters have canceled. Now I can find my mass with moles times molar mass. I didn't find my molar mass yet, so I'll have to do that quickly. Calcium is 40.08. There are 2 oxygens that are 16 and 2 hydrogens that are 1.01. So my molar mass is 74.10. So now I take my, again, unrounded moles, multiply by my molar mass. My moles are going to cancel and I'm going to get left with grams. So I scroll back up to use that unrounded answer. It was 0.0444569853. Then multiply that by 74.10. I get an answer of 3.294 so on grams. Now for sig digs, I'm looking back at the numbers in my question. I have a pH value, and the only sig digs in that are its decimal places. There are 2 decimal places in my pH value, so there's 2 sig digs in that number. My volume has 3 sig digs, total digits for volume. So I have to go with the lowest, which is 2 sig digs. Now what's significant in mass are its total digits. So I need 2 total digits in my answer, which would leave it as 3.3 grams. Okay? So if you have a compound question and you're looking for the mass of it, remember you need to first write its reaction. If it's a base, an ionic hydroxide, you just dissociate it. If it's an acid, you react it with water. When you have a base, you have hydroxide ions, so you need pOH. When you have an acid, you have hydronium ions, so you need pH. Okay? And then just follow those steps, again, kind of backwards from the steps of calculating pH, and that gets you your answer. Thank you very much for watching this video.